In this video, we are going to learn how we evaluate functions. So let's get right into an example. I want to evaluate each expression for g of x equals x squared minus 4x. So part A says g of negative 5. And what this means is the thing that's in the parentheses, it's not multiplying the g. What this means is the negative 5 is getting plugged in. So wherever I see this variable here, my x, I'm going to plug in negative 5 for it. And if I do that, I'll get, instead of x squared, I'll get negative 5 getting squared, and then minus 4 times negative 5. So negative 5, once I square it, becomes positive 25. And then I get my plus 20. And then adding those, I get 45. So part B, what if I have g of a? So again, this doesn't mean g is multiplying a. It means this thing in the parentheses is getting plugged into my function. So anywhere I see an x, I'm going to replace it with the a. I'm going to plug a in. So this is going to give me the quantity a getting squared first, and then minus 4 times a. And if I simplify this a little bit, well, parentheses a squared means a times a, which is just a to the 2, or a squared. And then minus 4 parentheses a, after I multiply them, I get a minus 4a. Okay, nice. All right, so I can do the same thing even if I have two terms added together in the parentheses. I'm going to plug those in where I see these x's. So that will give me parentheses x plus h in the parentheses getting squared. And then I get minus 4 times that quantity x plus h. 4 times x plus h. And I'm actually going to leave it like this. Even though if I wanted to, I could expand this x plus h squared. I could distribute the negative 4. So I'm going to specify for this problem for C. Don't simplify. So don't simplify for C, just because I'm going to include that in the instructions here. So let's end this video with what's called a difference quotient. So when I have a fraction that looks like this, g of x plus h minus g of x over h. So you're going to see these a lot in calculus. And in calculus, you'll simplify things like this and then do one extra step at the end, which is called taking a limit. But actually, 90% of those problems we can actually do now. It's purely algebra. So how do we do this? On the numerator, I see this g of x plus h, but we just worked that out. G of x plus h is this thing. So this first part of the numerator, let's go ahead and write that out. The first part of the numerator is that x plus h getting squared minus 4 times x plus h. So that's that g of x plus h. And then I got this minus sign, minus, and I got to subtract g of x. So, well, what's g of x? So that was given at the start of the problem. G of x is x squared minus 4x. So I got to take that and I got to write it here instead of writing g of x. So I got to do it here. When I first write it, I'm deliberately going to make a mistake to see if you can think and catch what my mistake is. So minus, I'm going to write my g of x, x squared minus 4x. And I've deliberately made a mistake. I want to have you pause the video just for 10 quick seconds to see if you can find it. So pause in 3, 2, 1, pause it, see if you can find my mistake. All right, so my mistake is this minus needs to apply to this whole thing, so I forgot to put a parentheses around it. Right, if I forget my parentheses, I'm going to forget that, wait, this negative actually has to get distributed to each of these terms. So I got that whole thing over my h in the denominator, and so the thing in this parentheses, that was my g of x. Now I got to simplify this. And then this is actually a type of problem that we've seen before. I want to have you pause the video one more time, this time for 3 minutes, to see if you can take it from here. Pause it in 3, 2, 1, pause it and try it. All right, so hopefully you did that. Hopefully you paused it and tried it. So let's talk about it. So I got this big old fraction. To do x plus h getting squared, remember that means x plus h times itself. And if you FOIL this out, you'll get x squared plus, if you multiply the outers and the inners, you'll get xh plus xh, which becomes 2xh. And then multiplying the last terms together, I'll get plus h squared. Then I got to distribute the negative 4. So minus 4x minus 4h. Distribute this negative into that parentheses, so minus x squared plus 4x. All over that h that's in the denominator. Oh, and now I notice there's an x squared here, positive one, and a negative one. Those just add to 0. I also see a positive 4x and a minus 4x that just add to 0. And now, if I look at the numerator, all the terms that are left actually have an h in common. So I can factor that h out. So factor that h out, which leaves me with 2x plus h minus 4, all over that h in the bottom. Oh, and now that this h has been factored out on the top, and technically the h on the bottom is also factored out because it's kind of multiplying a hidden 1, we can cancel those h's. We are allowed to divide the top and the bottom by an h. And that makes this h, if I divide it by h, become a 1. And if I divide that one by h, it becomes a 1. All right, so that leaves me with 2x plus h minus 4. And because there was a denominator originally in this, and now it's canceled away and disappeared, I need to remember my domain restrictions. So I need to put a comma, and what's got to be true about the denominator? Well, it can't be 0. So h cannot be 0. Anytime I'm simplifying a fractional thing and there's variables in the denominator that end up canceling away like this, I need to remember, wait, there's actually a domain restriction. That's very important. And we got it.